VFD brands like Schneider Electric, Siemens and RC Brown Boveri. Okay. And these are the list of the VFDs that we are having, and in this Schneider Electric Altiva 312 HU22N4 is the VFD model that we are going to configure. Okay, so I will be just telling you which all are the steps that we will be implementing into the VFD for configuring it, and make sure that you will be having a perfect note of that along with my lecture. You can note down the lecture notes, and once you move to the offline class in your station, you can make use of these lecture notes to get the VFD configured by yourself. Okay, so you'll be having the offline class and the training in VFD configuration. So while that time, you can just actually make sure that you make use of my lecture. Okay, so as I mentioned, the Schneider Electric Altiva 312, the perfect model is HU22N4. That is what we are going to configure now. Yeah, and this is the VFD. Okay, so it looks like this. And first of all, before moving to the configuration part, what we have to do and what we have to observe is the wiring diagram of the particular VFD that we are going to configure. Okay, so since this is the model of the VFD that we are going to see, we can see the wiring diagram. So this will be the wiring diagram of the VFD. Okay, so we'll be starting from the left top, that is power supply, single phase or 3 phase. That's the first component. Second component that you can say is 2 fault relays. One is R1, the other is R2. See, actually in the introductory class, you may came to know how to identify the types of relays. Basically, we'll be having 4 different types of relays: single pole single throw, single pole double throw, double pole single throw, and double pole double throw. These are the basic 4 types of relays that we'll be using. And these 2 relays are actually some of these types. So let's first identify which type relay R1 and R2 are. See, inside R1, you can see 3 terminals actually: R1A, R1C and R1B, right? And R1C is actually connected with R1B, and also the R1C is having a possibility to get connected with R1A, right? So R1C is actually having 2 connections, possibility of 2 connections, currently connected with R1B, and it can get connected with R1A. So from that case, we came to know that R1C is the common point of the first relay. And obviously the NC contact will be connected with common. So R1B, that is the NC contact or NC throw. Therefore R1A is the NO throw. So here we are having 1 common and 2 different types of throws that are. So from that we came to know that this relay is single pole double throw. Okay. Second one, we are having R2A and R2C. R2C is actually having a probability to get connected with R2A. So R2C is the common point or the pole, and R2A, that is the NO throw. So single pole single throw. So this is how we'll be identifying which type relay both are. Okay. So the next thing, moving to the right section, you can say Li1, Li2 till Li6. So overall all are connected with a common point of 24 volt. So those are the digital inputs of the particular VFD. So this VFD is actually having 6 digital inputs. To the down of that, you can say AI1, AI2, AI3, something of 0 to 10 volt, plus or minus 10 volt, 4 to 20 milliamps, etc. Right? So those are actually the AI stands for analog input, 3 analog inputs, AO with respect to voltage and AO with respect to C, current. So we can see 2 different analog outputs along with the reference potentiometer we are having it. So those are the analog sections. Moving to the left side of the analog section, you can see the braking resistor. So about the braking resistor, about the braking section, stopping methods, we'll be seeing later. To the left of that, you can see the motor actually. So this is actually the wiring diagram of the corresponding VFD. Hope you are clear with the wiring diagram. Next, yeah, this is actually the IO connections. we are having 6 digital inputs, 3 analog inputs, 2 analog outputs, and those are the addresses of the particular IOs. Okay, now we are moving to an important section about the configuration of the corresponding VFD. See, we are having 4 different and the most main configuration sections. First one is the driver configuration, DRC. So before moving to the inner core of these sections, let me make it one thing clear. You'll be having the VFD with you and we'll be either manually or with the help of the software, we'll be configuring the process, configuring the parameters that we are going to discuss from now. So first of all, we have to turn on the power. We have to make the VFD on. So after that, the VFD will be giving us the ready message. So once the VFD gives us the ready message, we'll be starting to configure. Okay. So the first thing that we'll be configuring is the details that are related to the motor to which we are configuring the rest of the parameters. That is actually what driver configuration means. So inside the driver configuration, you can see this list actually. When you are moving inside the driver configuration, we can see this list. First one, NCR, rated current of the motor. So we have to feed that rated current of the motor to the VFD. Second thing, there is a UNS, rated voltage. Third thing, the rated speed of the motor, NSP. Base frequency of the motor, BFR. Last one, the power factor, cos phi. So all these things you can say from the motor. So just move to the motor and you can see a steel plate in the motor and just take these values from the motor and just put it inside the VFD. Okay. Next thing, settings, the second one. So what actually settings is means, see, initially we'll be communicating, we'll be just running the motor. If the motor is in the 0 off condition, motor will be having 0 Hertz as the frequency, and if the motor is working, it will be having 50 Hertz in Indian standard, and if it's in the US, it will be like 60 Hertz, right? Yeah. So that's actually the speed variation of the motor. Now what we are going to do is we are just going to convert this manufacturer defined frequency range to the user defined one. That is actually what happens inside the settings. We are going to set the low speed LSP and the high speed HSP into the VFD. So once the motor is running, it will be working in the low speed, and the maximum speed it can achieve will be not 50 Hertz, it will be like the high speed HSP. So if I'm just going to set the LSP as 4 Hertz, HSP as 48 Hertz means when the motor is started to work in its initial speed, it will be working in 4 Hertz, and when the motor works in the maximum speed is 48, not the 50. So we'll just change the speed range to the user defined one. That is actually what happens inside the settings option. Third one, that is the IO configuration, IO. Inside IO, we'll be having 2 different options. This is the most prior thing, the most important thing. We're just going to change the direction. We're going to control the direction. So 2 things that are inside the IO configuration. First one is the terminal control configuration, TCC. Second one is the RRS, reverse rotation switch assignment, or simply we can say reverse assignment. So inside TCC, we'll be having 2 options, 2 control wire and 3 control wire, that is 2C and 3C. So as we all seen before, we are having the 6 digital inputs for VFD, right? Starting from LI1 to LI6. Okay. So what happens if we choose 2C as the option that are inside the TCC means defaultly if we turn on the LI1 switch, motor starts to run in LSP speed in forward direction. Actually this is the predefined value by the manufacturer. Once more I will make it clear. When we turn on the 2C option, and then after that if we try to turn on LI1 switch, the first digital input switch of the VFD means the motor that is actually connected to the VFD will start to work, start to rotate in forward direction with the LSP speed. Hope you are clear. And what is actually 3C? If we are providing the 3C option, not 2C means only if we turn on the first switch, if we turn on the LI1 switch, motor will start. That means the power supply will be moving to the motor. Motor will start, but it will not start to rotate. If you want to rotate it, if you want to start the rotation of the motor, means you have to enable the Li2, and if you enable the Li2, motor will start to rotate in forward direction. So this is actually predefined. So let it be 2C or 3C. We have to provide another switch for making the motor run in reverse direction, right? So let it be 2C or 3C. We have to assign another switch to make the motor run in reverse direction. For that, we'll be using the RRS option. Inside that RRS, you can assign any of the digital input switch, and when that particular switch is on, motor will be working in reverse direction. Okay, so let's take the 2C condition once more. So inside the 2C, if we choose 2C, means one switch, that is Li1, will be for start and forward direction, and then inside the RRS, you will be having another switch that is for the reverse rotation. So actually we just take the two switches only for starting and changing the direction of the rotation of the motor. So that is 2C, only two switches. 3C means if we choose 3C, Li1, that is for starting the motor, Li2, that is for finding the motor in forward direction. From Li3 to Li6, any of the switches that you can assign in RRS for the reverse rotation. So total of 3 switches. That is 3 control wire. Now I think just, yeah, okay with this IO configuration topic. Okay. Now we are moving to the application functions. So inside application functions, we are just trying to change this speeds. Direction is already done with the TCC. Now what we are going to say is about this speed orientation, speed changing. So let's take an example that I just choose 2C only. So Li1 is actually for the forward and start of the motor, and in RRS I just choose Li2. So we are having Li3 to Li6 freely with us. So first option that is inside the function is PSS, preset speed settings or preset speeds. So inside the preset speeds, what we have is PS2, PS4, PS8 and PS16. These are the 4 initial options that you can say when you choose PSS. And what we have to do is we have to assign some particular switches to these options. So currently I'm just going to take PS2 and PS4 only. So we are having Li3 to Li6 as the options in our hand for assigning the switches, and Li3 will be providing for PS2 and Li4 will be providing for PS4. I'm just taking the example, okay. So make it clear that this is not the original section. I'm just taking it as an example to make you clear with the speed settings. Okay. So Li3, that is for PS2, Li4, that is for PS4. So once I assign a particular switch in the option PS2, means we'll be getting speed option, that is SP2. So only when I assign a particular switch inside PS2, we'll be getting an option SP2 to assign a particular speed, and that speed should be inside LSP and HSP. So you can provide any switch, any speed, okay. Second case, here we are having PS2 with us and the PS4, right? So currently I'm just going to provide this switch for PS4. Let it be Li4. The switch will be having 2 conditions, either it will be on or off. So after assigning a particular switch inside PS4, we will be getting new 2 speed settings, SP3 and SP4. So inside SP3 you can assign a particular speed, inside SP4 you can assign a particular speed. So now it looks like a truth table, right? So when the both switches are in off condition, first of all we have to turn on Li1 or the Li2. Since I'm providing the 2C, Li1 means motor will start and rotate in forward direction. Li2 means motor will start and forward in reverse direction. So first of all we have to turn on that switch. After that, if these both switches, that is Li3 for PS2 and Li4 for PS4 are in off condition, motor will be working reference speed. Reference speed in the sense LSP. Okay. And then if the PS4 switches, that is the Li4 is off and only the Li3 is on, that is PS2 switch is on, means motor will be working in the speed that we provide for the SP2. And then if Li4 is on, that is PS4 is alone on 1-0 condition, right? Speed will be like SP3. And if both the switches are in on condition along with the Li1 or Li2, motor will be working in SP4 speed. So this is how we'll be just providing the speed conditions. Next thing, that is the jog conditions. Jog in the sense for an emergency situation, like in case if the motor is working and suddenly we came to know that some crack sounds or some dissimilarities or some deformalities actually happening inside the motor and is making some disturbances in the smooth functioning of the motor, so that we have to suddenly move to very low speed of the motor running. For that, we'll be assigning a switch inside the jog option, and the corresponding frequency will be set inside jog frequency, that is JGF option. So when the jog switch is actually activated, let it be in the digital speed or the analog speed. Prior thing, most priority will be provided for the jog condition. Motor suddenly move to the jog condition, jog frequency. And then we'll be having the stop controls, stop techniques or stop types. 3 different stop techniques are actually we'll be having inside the VFD. First one, that is the DC injection. Second one, normal stop. Third one, ramp stop. So DC injection in the sense, if you're having an emergency situation, like we can't move the motor, we can't just run the motor an inch more. So we have to stop it suddenly. We will be providing DC injection to an AC motor. Motor will suddenly stop. Second thing, in the normal condition, we will be providing the normal speed. So we can just provide the normal stop there to stop the functioning of the motor. Third thing, that is the ramp stop with respect to a particular time period of time. After that time period, and motor will be stopped with the injection of DC. So these are the stop techniques, jog application, and the preset speed settings that you can see in the option, that is function. Okay. So actually with this, we came to the end of the theoretical part of the VFD. So let me give a brief idea that what we discussed today. First of all, we just start with what a motor is, what's the working principle of the motor, different types of motor, the equation that drives motor, that is speed is equal to 120 F by P, how frequency is related to the motor, what is the importance of VFD, which all are the parameters that we have to control of a motor when we are in the plant or when we are in the real industry. Then we say the application of VFD, importance of VFD, block diagram of VFD, how with the help of the VFD we can control the speed and the direction, which all are the things, which all are the components that are inside the VFD. And after that we came to the second phase about the VFD.